So this is the practice assignment for the retake on the test for Unit 6. And first of all, we're asked to convert this angle to that's written in degrees to radians. And if it's on the unit circle, you could definitely look at your unit circle and see that you have 60 degrees and it's pi over 3 radians. But in another method, we could multiply by the ratio that pi and 180 are the same value. And if I multiply this by the ratio where the degrees cancel, I have a 3 left on the bottom, and this is pi over 3. So negative 480 degrees. I could go backwards around my circle as many times as it takes me to get to negative 480. But I can also use this method up here. So if I start with negative 480 and I multiply that, and that's degrees, by my ratio of pi over 180, I just need to simplify my fractions here. So these are kind of big numbers, so I'm going to do this in a couple steps. So I have negative 48 pi over 18 because I divide by 10. If I divide by, I see 6 goes into both of these. 6 times 8 is negative 48, so that's 8 pi, and 6 times 3 is 18. All right, so negative 8 pi over 3. Number 3, I'm drawing an angle. So 135 degrees, and if I put this in standard position, I know this is 90 and this is 180, and if I add these up and divide by 2, I'm going to get halfway in between. This is going to be 135 degrees. Number 4, same thing. I'm going to put this angle in standard position, and I have 5 pi over 3. So if this is 0 and this is pi, that would be 3 pi over 3, and then all the way around would be 6 pi over 3. That's 2 pi. So I need to have 5 pi over 3. So if I say, okay, here's 4 pi over 3, and 5 pi over 3 must be right here. So my angle is going to start at 0 and go around to 5 pi over 3. Okay, so this is my angle right here. Number 5 asks us to convert radians to degrees. So I'm going to use that same ratio that I did up here with pi over 180, except for this time pi is going to go in the denominator so they can cancel, and 180 will go in the top. And if I multiply, or actually divide 5 into 180, that is 5 times 3 is 15, so that's 36 degrees. Next one, 180 degrees on top. I want to end in degrees. Divided by pi, the pi's cancel. And now I have 11 times 180 divided by 12. I'm going to cancel common factors. I'm going to divide both of these by 12. So 12 goes into 12 one time, 12 goes into 18 15 times. So this is 11 times 15. 10 times 15 is 150 with another 15, so that's 165. See, no calculator needed. Number 7 asks us to find the sine of t. So here we have coordinates that are on a unit circle, and that's what this means right here in the directions. The point is on the unit circle. So the first point is cosine, the second point is sine. So sine of t is the second coordinate, or the y coordinate, and that's a square root of 11 over 6. Now tangent is, we have sine and cosine, so for tangent I'm going to have to divide. Sine divided by cosine. Sine is the square root of 55 over 8. Cosine is 3 over 8. If I were to multiply by the reciprocal, the 8's are going to cancel out, and I'm going to have the square root of 55 over 3. Number 9 asks us to find the exact value. Do not use a calculator, and we can do this by using our unit circle. So I'm going to just leave that here, maybe zoom in a bit. So the first one asks me for cosine of 0. And again, up here, cosine is the first number. So I want 0 to be, whoops, I'm looking at the angle of 0, and cosine of 0 is 1. Then I have cotangent of 3 pi over 2. Now cotangent is 1 over tangent. So if I look at the angle 3 pi over 2, tangent is going to be sine over cosine. So tangent, I'll write it over here, tangent is -1 over 0. So cotangent is going to be the reciprocal, which is 0. Whoops. That's there. Then I have tangent of 6 pi. And if I think about 6 pi, it's not on my unit circle. I could go around. Here's 2 pi. Around again is 4 pi. And around again is 6 pi. So this is the same thing as saying tangent of 0 pi or 2 pi, either one of them. So tangent is sine over cosine, which in this case is 0 over 1. That's 0. Cosine, pi over 4. Cosine is the x-coordinate. Pi over 4 is right here. I have square root of 2 over 2. Cosine of 60 degrees. 60 degrees is here. Cosine is the first number, that's 1/2. And then cosine of 8 pi over 3. So this is the same thing as if I'm counting around the circle. Around the circle is 2 pi, but if I put it into a common denominator, that's going to be 6 pi. So I'm going to take away 6 pi over 3, sorry. So this is 2 pi. So I'm going to take away multiples of 2 pi until I get something that's between 0 and 2 pi. So if I do 8 pi minus 6 pi, I get 2 pi over 3. That angle is right here, 2 pi over 3. I'm looking at cosine, which is -1/2. So cosine 2 pi over 3, -1/2. Flipping it over. Number 15 is asking us to find the exact value of the expression. So we're going to find the values of cosine and tangent of those angles, and then we're going to add those values together. So if I look at pi over 3 is the 60-degree angle, cosine is 1/2. And now I need tangent of 5 pi over 3. Well, 5 pi over 3 is way down here. So tangent is going to be sine over cosine. So I have negative square root of 3 over 2. And I'm going to calculate this over here. Divided by 1/2. So let's multiply by the reciprocal. Okay, or I could just write it as this divided by 1/2. Division is multiplied by the reciprocal, so this gives me minus square root of 3. And I can't combine a real number with an irrational number, or I can't combine a rational with an irrational number, so this is my answer. Number 16, what numbers for angles is secant not defined? All right, so secant is 1 over cosine. So if I want to know where it's not defined, this value has to be 0. Cosine is the x coordinate. And if I look here, I've got a 0 at pi over 2, and I have another 0 at 3 pi over 2, and then I have another 0 at 5 pi over 2. So I'm going to have pi over 2, 3 pi over 2, 5 pi over 2. And if you remember, these are odd numbers times pi over 2. So it's multiples of pi over 2. And that would be 2 times a number would give me an even pi over 2. But if I subtract 1, this is an odd number. That's how we designate an odd number, pi over 2. Whoops, I wrote that over here. Number 17, what is the range of the cotangent function? Now, cotangent is the reciprocal of tangent, and those graphs look like this. And remember, we have the asymptotes in between. So the range of the cotangent function is going to be all real numbers. That's up there. So this one is real numbers. Number 18, we have sine of 17 pi over 3. Now the directions say to find the trig functions, remember they're periodic, so that means they keep going around and around in the circle, and we want to find the exact value of the expression. All right, so 17 pi over 3 means I'm going to go around the circle more than one time. So if I take away multiples of 6 pi over 3, which remember we just said that that was 2 pi. If I start with 17 pi over 3 and take away 6 pi over 3, this is going to be 11 pi. Whoops, 11 pi over 3. Now, this is still bigger than 6 pi over 3, so I can take another one away. So minus 6 pi over 3 again. 11 minus 6 is 5 pi over 3. So if I'm finding sine of that angle, 5 pi over 3, I can use my unit circle, find 5 pi over 3. Sine is negative 3 square root of 2. Number 19, name the quadrant for the angle. Tangent greater than 0 is positive. Sine less than 0 is negative. So if I think about my quadrants where tangent is greater than 0, all right, so remember, all students take calculus. Okay, all of them are positive in quadrant 1, and tangent is positive in quadrant 4. So for tangent, this is quadrant 1 and 4. Now I want sine to be negative. Well, sine is positive in the first quadrant, sine is positive in the second quadrant, and sine is negative down here. Okay, remember sine is the y value, so where is the y value negative? And that's in quadrant 3 and 4. So where they overlap, or where they are the same, is where this happens, and this is in quadrant 4. Number 20, sine is greater than 0, so that's positive. Cosine is less than 0, so that's negative. Okay, so sine is positive, sine is the x value, so that's positive in quadrants, 1 and 2. Sine is the y value, quadrants 1 and 2. Cosine is negative. All right, so they're all positive here. Sine is positive, cosine is negative in 2 and 3. Okay, only tangent is positive in quadrant 3. So cosine is negative in quadrants 2 and 3. So it looks like the quadrant that matches up is quadrant 2. Number 21, they want us to find the exact value of the trig function. It gives us sine and cosine, so we want to find cotangent. I know that tangent is sine over cosine, and cotangent is going to be the reciprocal of this. So cotangent is cosine over sine. So cosine is the square root of 15 over 4, and sine is 1 over 4. So if I multiply by the reciprocal, or I can do this, the 4's will cancel, so I'm left with the square root of 15. Number 22, find the exact value. Here I have cosine of the angle is 2/5, and it says that tangent is negative. Now, 2/5 is not on my unit circle, so I'm going to draw this angle over here on a unit circle, and I got to decide which quadrant am I going to put it in. So cosine is positive, and that happens in quadrants 1 and 3. Tangent is negative, and that happens in, this is positive for tangent, 2, and this is positive 4. Oh, cotangent's positive in 1 and 4. All students take calculus. Cosine is positive in 4. So we're going to draw our angle in quadrant 4. Here's our, whoops, that's not our angle. Here's our angle. And cosine is opposite over hypotenuse. So this angle, the opposite is 2. And the hypotenuse is 5. Now I need to find this value. So this value here, cosine is negative down here. Cosine is positive, but if tangent is negative, both of these numbers have to be negative. Okay. Both of the numbers here have to be negative. So I'm trying to find my x value. So that if I use the Pythagorean theorem, I have x squared plus negative 2 squared equals 5 squared, or negative 5 squared. This is 25 equals x squared plus 4. So x squared is 21. So x would be square root of 21. So this x value up here is the square root of 21. I'm finding now that I have the 3 sides of the triangle, I'm finding sine. Sine is opposite over hypotenuse. So the opposite side is negative 2. The hypotenuse is negative 5. And this sine, which is positive here, whoops, I have a sign missing. This hypotenuse should be 5, I'm sorry. So this should be negative 2/5. Opposite over hypotenuse. Phase shifts. Phase shift is coming from the formula minus c over b. Now in our equation, the negative 3 is a, b is the number multiplied by x. In this case it would be 1. C is this number right here, which is negative pi over 4, and my d is what's being added to this, so I don't have anything here. But I need to know the minus c over b numbers. The opposite of negative pi over 4 is pi over 4, and divide it by b, which is 1, and that gives me pi over 4. This one, I have the opposite of pi, which is minus pi, over the b value, which is 6. So minus pi over 6. So this would go to the right, pi over 4 units, and this would go to the left, pi over 6 units. And lastly, we are going to graph a function. I don't like how this is labeled here, so I'm going to label my own graph. I'm going to call this 1, 2, 3, 4. 1, 2, 3, 4. It's negative 4, negative 2. And, all right, so what I'm looking for here, I need to know the amplitude. So the amplitude of this is 2. My period for sine is 2 pi over b, and b is 3, so I have 2 pi over 3. That's my period. My phase shift, this is going to take my starting point from 0 and shift it left or right. So my phase shift is the opposite of c, so this is minus pi, so I have the opposite as positive pi over b, which is 3. This actually is going to be my starting point, so I'm just going to make a starting point here, pi over 3. I'm going to have an ending point here. To find my ending point, I'm going to take my starting point. So my starting point is pi over 3, and I'm going to add my period, which is 2 pi over 3. So this is 1 pi over 3 plus 2 pi over 3 is 3 pi over 3, or just pi. Now I need to find the number that's halfway between them. So I'm going to add them up, divide by 2. So 1 pi over 3 plus 3 pi over 3 divided by 2. So this is 4 pi over 3 divided by 2 means multiply by 1/2. So I can cancel here. So I have 2 pi over 3. So in the middle, 2 pi over 3. Sorry. So now I need to find my halfway point here and my halfway point here. So my next thing I'm going to do, I'm going to find the midpoint between pi over 3 and 2 pi over 3. So 1 pi over 3 plus 2 pi over 3, and halfway divided by 2. This is 1 plus 2 is 3 pi over 3 divided by 2. The 3's can cancel, so I have pi divided by 2. So this is pi halves. And now I have one more. So I'm going to have 2 pi over 3 plus 3 pi over 3 divided by 2. So this is 5 pi over 3 divided by 2, or 5 pi over 3 times 1/2. So this is 5 pi over 6. All right, so that was the hard part. I know in a sine graph, usually I start at 0, 0. This time I'm going to start here. I'm going to go with my next point up, however high my amplitude is, and it's 2. Back to the 0, 0, down to -2, and back up here. So this is my sine graph of this function. All right, so that's it. Good luck on your retake.